start with chapter 13. Does anyone have any questions on chapter 13 on your online homework? Anyone have any questions on your online homework, chapter 13? All right, so if you have homework questions, you can either talk to me or you can type it in the chat room, okay? So we start out with the notes for 13.1. So we've got 3 sections of chapter 13. We do not do 13.4. So we have sequences on 13.1. So we'll talk about this sequence right now. So I think a lot of you guys know what is sequence in this case. The main part about here is how do we need to factorial notation, okay. In this case, we need to know how to figure out how you write sequences in a NaN form. So if you have like 1, 4, 7, 10, 13, this is called an arithmetic sequence. The arithmetic sequence is a very easy to write on this sequence. Is how do you write an arithmetic sequence in this case? Is this is a wrong answer, should not be 3n plus 1. So what you need to do when you have an arithmetic sequence, your sequence is actually finding what is the difference between the first two. In this case is 3. So you got 3n, and then this answer should be 3n minus 2. So how do we figure out the minus 2 in this case? This should be 3n minus 2. How do we figure out minus 2 in this case? Is you subtract 3, the difference from the first one, you get a negative 2. So that is where the negative 2 comes from. So every time when you guys have an arithmetic sequence, your arithmetic sequence in this case should be how we written down as the difference between those two. And then you find out what is the difference, what is the zero term, we call it the zero term in this case. That is how you figure out your arithmetic sequence in this case. So for example, is if I give you a sequence that start with something like this, words coming up here. So another type of sequence you have to write is alternative signs. So in order for you to change from positive to negative, then back to positive to negative, then you have to add this negative 1 n plus 1. But if you start from negative, then to positive, then to negative to positive, then it's negative 1 to the power of n. So this is the alternative sign in this case. And then we have a recursive sequence. A recursive sequence is where it is a sequence that uses previous terms. It's kind of recursive in this case. It usually has a formula given to you or equation. So that's the reason why that you have what we call as a recursive. You will get some examples coming up here. So example that I've told you about the arithmetic sequence in this case is something like this. So if you have an arithmetic sequence, so if you start from, let's say 3, 8, 13, 18, and so on. So we know this is having your difference is 5 here. So how do you find your AN form? Your AN form is very easy to figure out. Is you use the difference 5n, and then what you do is you try to figure out what is a number before this. So if you can figure out that number, then that number will be over putting behind the 5n. So how do you figure this number is you subtract 5. So 3 minus 5 is negative 2. So we know this sequence will be 5n minus 2. So this is how we figure out your arithmetic sequence in this case. It's not that tough. So how does the AN works? Okay, the one that I showed to you about the AN about your changing signs work is is if you have sequence something like this, 2 over 5, and then 4 over 6. Then this is 1 is plus, 1 is minus, and then you got like 8 over 7. And then you got negative 16 over 8. So, so how do we figure out the AN form in this case? This is very important because it will be asked in the question, in your test, and probably in your finals. So in order for us to find the AN sequence here is first, usually we put it down. This is your 1, your 2, your 3, your 4, and your 5. We kind of like label them 1, 2, 3, 4. So the first thing you notice that it is plus and then minus and then plus and then minus. So in this case that if you start with plus and then minus and then plus and minus, then you will need this -1 n plus 1. So for this question, you will have a -1 to the power of n plus 1. This is used because of your sign is alternating from plus, minus. And then after that, you have to figure out how do you figure out this 2, 4, 8, 16. So in order for us, the top one, so you find out that 2, 4, 8, 16, they're all being multiplied by 2. So in this case, it will be 2n. This is how we figure out the top one is 2n. And then the bottom one, you figure out the numbers start from 5, 6, 7, 8. So it's the bottom one is an arithmetic sequence because it starts from 5 and then to 6 to 7 and to 8. So for arithmetic sequence, we know the difference here is 1 because you keep on adding 1. So it's n. And then you had to figure out, in order to figure out the last number, you had to figure out what is the one before 5. So that will be 4. So in this case, that it'll be n plus 4. So in order for us to figure out this arithmetic sequence in this case, your answer in this case should be -1 to the n plus 1 because your sign changed. 2n is because your numerator is multiplied by 2. Keep on doing by 2. And then n plus 4 is because your numerator is an arithmetic sequence. So this is how we figure out your AN term. And you can always plug in n as 1, and you should get 2/5. And when you plug in n is 2, you should get -4/6. And then 3 is 8 over 7. This is not actually 2n. It should be 2 to the power of n. It's not 2n because when you put 3 here, 2 times 3 is 6, but we got 8. So 2 to the power of n is correct because 2 to the power of 3 is 8. 2 to the power of 4 is 16, 2 to the power of 2, so it's 2 to the power of n in this case. So this is how we figure out your AN term if I give you an arithmetic sequence. That is one of the most difficult part that we have. Next, we talk about factorial. So Tyler asking me about factorial notation. Factorial notation is just a factorial in this case, which is an exclamation point. It's just keep on multiplying. So if you have 5 factorial is 1 times 2 times 3 times 4 times 5. 6 factorial is 1 times 2 times 3 times 4 times 5 times 6. So when you have the factorial, you multiply all the way up to that number that we have. So that is called a factorial in this case. 0 factorial is 1. So in this case, that, for example, is if I want you to figure out what is 10 factorial, so what you need to do is you take 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8 times 9 times 10. That's it. And use your calculator and multiply all this number. This is a very big number in this case. So Tyler, that is the factorial that you're asking for. Are you okay with that one? Tyler, factorial. Okay, so this is the meaning of factorial. You multiply all the way, multiply, not add. So if you guys remember that 1 factorial is 1, 2 factorial is 2, because 1 times 2 is 2. And then 3 factorial is 1 times 2 times 3, which is 6. So another way for us to figure out is you take your previous, like 4 factorial, you multiply 6 times 4. So you take your previous answer, you multiply by 4, which is 24. And then 24 factorial, 5 factorial, not 24 factorial. 5 factorial in this case is you take your previous number, which is 24, and then you multiply by 5. So 24 times 5 is 120. And then 6 factorial is you take 120 times 6, so that will become 720. So usually if you guys want to figure out factorial, if you want to do it like in the order like this, you just take your previous term multiplied by the number that you have. That is how you figure out your factorial here. So this is the, if you have a sequence that looks like 1, 2, 6, 24, 120, 720, this is what we call as n factorial. So example is, if I want you to write in a sequence that looks something like this, 1 over, let's say, 4. Let's start with the negative. And then the next one we have is 2 over, let's say, 7. And then the next one we have is a negative 6 over, let's say, 10. Usually we don't reduce the fraction here so you can see the pattern. Otherwise, you will having a hard time if the fraction has been reduced. Next one is 24 over 13. And then the next one is negative 120 over by 16. So can someone figure out what is your AN term in this case? Anyone? This is something you get in your test. So you guys need to know what's going on here. Anyone know what is an AN term in this case? Anyone? Question? Anyone? You can talk or you can type. So first thing you need to do is watch out for your sign. Your sign is negative, positive, negative, positive, negative. Okay. Is it better, Munira? So how do we figure out the plus minus is first you have to figure out which one come first. So so this one you find out that the negative come first. So if a negative come first, you have to use this formula because this is where the negative, positive, negative, positive. So your formula in this case is going to be -1 to the power of n. Okay, that's the formula we use. So this is how useful this formula is to figure out if your sign is changing from minus, plus, minus, plus, minus, plus. What else do we do? Does anyone know what is your numerator looks like? 1, 2, 6, 24, 120. Anyone know what's that number for? 1, 2, 6, 24, 120. Anyone? This is very important. 1, 2, 6, 24, 120. No. We just did it just now. What is 1, 2, 6, 24, 120? That is your factorial. 1, 2, 6, 24, 120. This is your factorial. So the numerator in this case is n factorial. And then anyone know how to create 4, 7, 10, 13, 16? So how do you figure out this? Is this arithmetic sequence? 4, 7, 10, 13, 16, the denominator. Is that arithmetic sequence? Anyone? Tyler, Munira? Is this an arithmetic sequence? You guys are worried about you guys now. This is what you get in your test. So this is an arithmetic sequence, not n plus 3. It's an increasing, the difference here is 3, so it should be 3n. Should be 3n. Yep, the difference is 3. And can you tell me what is a number before 4? Can you figure out what is a number right before 4? 1, so it's 3n plus 1. So the 3 come from the difference, because we know the difference is all 3. And the plus 1 came from the number right before it. So this is how you figure out, this is your AN sequence in this case. Okay, so so this is the what we call as your AN term. So if you look at the very end of the second page here, the very end here, you find out that there's a hint here. So if your sequence is 1, 2, 3, 4, 5, it's just n. If your sequence is 2, 3, 4, 5, it's n plus 1. If you have any odd numbers like 1, 3, 5, start with 1, 3, 5, 7, 9, then it's 2n minus 1. If you have even like 2, 4, 6, 8, 10, it's 2n. If you have n factorial, it's 1, 2, 6, the one that we just did, 1, 2, 6, 24, 120, 720. If you have a negative one, n plus 1, it means that you start from positive, then you're negative, then positive, then negative. Your sign's been switched, but positive come first. And then negative 1 to the n is also switched, but negative sign come first. So this is how you figure out your AN term, which is the most important thing in this case. So I think there are some questions here online who are asking for that. Okay. The next one we talk about is a summation notation. What is summation notation? A summation notation is where you start from, given you a sequence and you keep on adding. And then this is a summation notation here. This is your index k. That means your variable kind of what we use as an index. This one is your lower limit. The n is your upper limit. So if you have 1 till 5, means you had to add 1, 2, 3, 4, 5. You had to add the first 5 terms in this case. Okay. There are some properties here, and these properties you do not need to memorize these. You just need to know how to apply it. These properties is actually given in your task, so you do not need to, again, memorize the formula. You just need to know how to apply it. So if you have a constant, C is a constant, any number you want, multiplied by a number, AK, a term. So this C actually can be put out. So this C, you can put it out, so C times of it. So for example, if you have CAK1, means CA1 times CA2 times CA3 times CA4. This C can be factored out, and you will get these properties of the sequence. C is a number in this case. If you have two different sequences, you can add them up. But if you add them up, you can actually split into two. Okay. If you have subtract, you can subtract these two sequences up, or the terms. And if you have j plus 1, if you want to add something that is like, let's say you want to add from 5 till 9. So what you do is you add from 1 till 9, and then you do 4 till 9, 1 to 4, sorry. So when you add something from 5 to 9, so what happens here with this equation here, this last, the fourth functions that we have here is that if you want to add the sum, sorry, it's hard to put the sum. If you want to add the sum from 4 to 9, so what you need to do first is you sum it from 1 to 9 first. And then after that, you subtract it from the sum from 1 till 3. So, so what happens in this case is if you want to add like a partial sum, we call it. So what you do is you add everything from 1 till 9 first, and then you minus from the 1 from 1 to 3. So this is a formula for number 4. This is only happens when you have a different summation here. The next one that we have is the formula of the sum. So if you want to add the same constant like n times, you just take n times c. This is a constant again. So if you multiply, if you want to add this, it's just adding c plus c plus c plus e n times. So that's why it's n times c. This is very important if you go to calculus. That's why it's written down here. This is all in calculus 2 actually. So this is called sequence. If you want to add 1 plus 2 plus 3 plus 4 plus 5 all the way to n, the formula is n times n plus 1 over 2, where n in this case is how many terms you want to add. If you have a square, 1 square plus 2 square plus 3 square plus 4 square, I can hear audio. I think everyone can hear me except for you, John. Maybe you need to, can you guys hear me? Can you guys hear me? I thought you guys can hear me. Yeah, Munira said you can hear me. So I don't know, can you guys? Yeah, you have to click something on it. So if you have 1 square plus 2 square plus 3 square, so if you have a square part, then you have n times n plus 1, 2n plus 1 over 6. And then finally for K3, if you have a power 3, if you add all your power 3, that is n times n plus 1 over 2 square. Again, class, these formulas that I written down here, you do not need to memorize it because it's given in the test. You will use this a lot in calculus 2. Okay, so let's take a look at your homework here, so you know what it looks like on the sequence piece here. So I think the first few questions are pretty straightforward type. I'm not going to show you how to find the first 5 terms because that is very easy. Because that is something that you guys should know how to do it, because you just plug n is 1, n is 2, n is 3. So like this kind of questions, I will not show to you because it's very easy. You just change n is 1, n is 2, n is 3 for it. So, so finding the first 5 terms is very easy. This is the one that I'm talking about, is how do you write this in AN? So does anyone here has any clue how to write this in AN? It's a fraction, so you need a fraction symbol for sure. So how do you write 1, 2, 3, 4? Anyone know how to write this in n term? 1, 2, 3, 4. This is something you will get in your test. Very important. How do you find this? Again, it's the top one arithmetic sequence. 1, 2, 3, 4. Are they arithmetic sequence? You guys know what's arithmetic sequence, right? Keep on adding the same number. So is this an arithmetic sequence in this case? Yes, it is. So what is the difference between 2 to 1, 3 to 2, 4 to 3? The difference is 1. So that means that is n. And can you tell me what is the number right before 1? 0. So that's why you got n here. So n plus 0, which is still the same as n. And now look at your denominator. Is a denominator arithmetic sequence? 2, 3, 4, 5. This is also an arithmetic sequence, and your n, your difference here is 1 again. Yes, so it's n. But can you tell me what is the number before 2? So it's n plus 1. So this sequence is n on top and n plus 1 on the bottom. And if you want to check, you can check by plugging 1 in here, and you get 1/2. You can check by plugging 2 in here, you get 2/3. 3, you get 3/4, and 4, you get 4/5. So this is how you figure out your arithmetic sequence in this case. Type the nth term of sequence. So this is the same thing here. So the first one is all 1, 1, 1, 1, 1. So that means that your answer is still a fraction. So since on top is all 1, so your answer will be 1. So this is very easy. Now, if you look at this, it's 1 to 8. 8 till 64, 64 to 512. Does anyone know what to do here? 1 times become 8, 8 becomes 64, 64 becomes 512. So how do you get from 1 become 8, and then 8 becomes 64, and then 64 become, so you multiply this by 8. So every time when you multiply by 8, we call this as a geometric sequence. So in this case, you will have to use 8 to the power of n. But if you use this, it's very easy to figure out if it's right or wrong, is you figure out what is n here. If n is 1, you got 1/8. I don't get 1/8, I get 1. So 1/8 is the one that is 1 before that, after that. So what you do here is you just subtract it from 1. Okay, so if you find your answer, when you say I plug n is 1 and I got 1/8 and I figured that 1/8 is actually, it's not the first term, it's the second term. So it's very easy, you just minus 1 it. So now when you put 1 here, what is 1 take away 1? 1 take away 1 is 0. What is 8 to the power of 0? Anything to the power of 0 is 1. So 1 over 1, you get 1 here. So that's how you figure out your first term. Your second term is when n is 2. So you will get 2 minus 1, which is 1. So you get 1/8. And then 3 minus 1, the third term is 2. 3 minus 2, 8 squared is 64. So you figure out that this is how you figure out this. So if you have we call this as a geometric sequence, okay? So those students who have know what is, this is called a geometric sequence because if we multiply 8 every time, you will learn this in 13.3. So this is, then you figure out it's a power. So if a geometric sequence is a power sequence, so it's 8 is because you multiply it by 8. The n is where it starts, and then you have to minus 1 because of your previous term. Okay. So these are things that you have to really work on, something that you have to do. This one is very easy. It's because your sign is alternating, but then you have to figure out how do you alternate first. So is it alternating with negative or positive first? So this alternating sign starts from negative, then positive, and then negative and positive. So which one should we use for if you have alternating sign from negative to positive, then to negative to positive? Is that the first one or the second one? First or second? Second one. So yep, so you need to type this -1 to the power of n here. So that is to tell us they are alternating. What you multiply here is because they're all 8, 8, 8, 8, 8, 8, right? So that means that you just multiplying this with 8. So that means that when n is 1, you get -8. When n is 2, you will get 8. Because when you square this, is +8. Okay, so so this is how you figure out your answer here. It's not that difficult, so make sure that you use as much help as you guys can. Can someone figure out what is this going to be? First is the alternating sign. So what sign should we use for this one? First one or the second one for this question? It's alternating from plus to minus to plus to minus. So which one should we use here? The first one. So you have to type in -1 to the power of n plus 1. And then now you figure out what is this is. So ignore all your negative. So how you get from 7 to 14 to 21 and then to 28. 7 to 14 to 21 to 28. This kind of like an arithmetic sequence, right? What number do we add here? Anyone know what number should we add here? What number should we add in this case? Anyone? 7. So that means this one have a 7n. And can someone tell me what is the number right before 7? Because that's a number you have to put in here. Any number is right before 7? 7, 14, 21, 28. What's the number right before? It's 0. So that means that your answer here is just 7n plus 0, which is in this case is 7n. And then check your answer is plug n to become 1. You will get 7. When you plug n to become 2, this become -14. And then so on, so on. So that's how we figure out. So what you need to watch out is it's not that difficult when you write this in a pattern. So this is called a recursive pattern. Recursive pattern means you use your previous term. So like here, the first one is 7. So if you want to find the second one, that means you put n is 2 here. So when n is 2, you get A2 or A1. So A1 is 7. So this one is given to us already. So we know it's there. So in order for you to find A2, recursive, So you put n is 2 here, is 1 plus whatever previously. So in this case, it's 1 plus 7. And 1 plus 7 in this case is 8. And then the next one is A3. In A3, this is A2 now, because when n is 3, this is A3, n minus 1 is A2. So that means that you take 8 here, the previous one, and then you increase by 1, so you get 9. So what happens to here is, for a recursive, is you use your previous term, and you find out that if you use your previous term, you keep on adding 1 to it. So can someone tell me what is the A4 and A5 in this case? You can see the pattern, 7, 8, 9, and then what's next? This is 10, and then followed by 11. Yep. So so it's pretty straightforward. Recursive is actually, the formula looks tough, but once you know your first few terms, then you'll be fine here. So for this one, we know A1 is -1. It's given to us. So is that. So to find A2, you use your previous term, and then you add with n. And n in this case is 2. So 2 plus your previous term, 2 plus -1. What is 2 plus -1? 2 plus -1 will give us 1. Okay. And then A3, you use your previous term, and then you add with n. So you add 3. So you add this term, the previous term, which is 1 plus 3. And 1 plus 3 is 4. Now, this one doesn't have a pattern because it's very weird, -1, 1, 4. So we don't have a pattern. But the pattern is very straightforward type, is you take your previous term, and then you add with the term that you have. So like 1 plus 3, you see the 1 and the 3 here, you add them up, become 4. So the next one is 4 plus 4. So 4, and then you add with the fourth term. So 4 plus 4 is 8. So what is the last term? Anyone know how to figure out the last term here? Anyone know how to find the A5? So this is not that tough, this kind of homeworks. So anyone know how to find the fifth term? You take what? The 8 that you have and the 5 that you have. So 8 plus 5 is 13. Yep, you're right, Munira. So it's not too difficult. So the most, we'll do the summations part here. So these are all based on summation. So what is k plus 5 when you have k equals to 1? N is to substitute k in this case as 1. So 1 plus 5 is 6. And then you increase your k to become 2. So 2 plus 5 is 7. And then increase k to become 3. 3 plus 5, 8. But don't forget, this dot, dot, dot means you go on. So the last one is you use the last term, which is n. So you substitute k become n. So that will become n plus 5. So this is how you write you just substitute k become 1, k become 2, k become 3, k become 4, and then the last term is k become n. And this is how you figure out your sum in this case. Okay. Does anyone try this question? Actually, this is not bad. K is 1. What is k is 1 is? Does the sigma mean anything? The big sigma sign means you add. Okay. The sigma sign here that you have means you have to take this and you add that. Okay. And then when you go above Cal 3 and above math, above your college math, we will sometimes symbolize the sigma with a pi symbol. So if you have a pi symbol, we don't add, we multiply. So that's the meaning of, if you have a sigma, means you add some. If you have a pi, which you will learn it in above Cal 3, this is like way above you guys, you will have a pi sign. The pi sign means we multiply. So that's the meaning of sigma in this case. Okay. So anyone know what this one is? The first one. When k in this case is 1, so what you get when k is 1? 1/6, yep. And then next, k is 2. What you get? That will become 4/6. I don't think so. You need to reduce your fraction. So fully reduce. So what's a reduce of 4/6 is 2/3, right? So make sure you reduce your fraction. And then the last one here is where k is n. So when you have k is n, this will become n to the power of 2 and 6. You guys all right here so far? So these are all pretty straightforward type. Now we begin to find the summation. This one is 1, 2, 3, 4. So this is going to be k, because k is 1, 2, 3. And where do we end? We end at 31. So this is where you symbolize your fraction here, your not fraction, your an term. So your ak term, your k here. And 31 is because we end at number 31 here. Okay. So it's very straightforward type questions. It's not that difficult. So the rest, you guys, this multiple choice. This one, you can figure out that this is all goes to the 8th term. Okay. So this should be 8th term. No, it's not 8th, it's actually 9. Why is 9 is tricky? 0, 1. Oh, it's actually 8 because it starts from 0. So this is 0, this is 1, this is 2, this is 3, 4, 5, 6, 7, 8. Yeah, 9 to the power of 3 is 729. This one is your rotating sign. Remember the sign I teach you? Is that, so what do we start at? Is that positive or negative? We start from positive. So which sign do we need to use? We have to use this one, but it's so weird they have a K here. So so it should be a negative one here. When K, oh yeah, because the reason why is because your K is 0, so that's why it's tricky. Anything to the power of 0 is a positive 1, so that's why we have that. And this one is going to be 9 because it's following. You can tell that it's following this term. Do you see the last term you see here? Okay. So this last term, this last one that you see here will tell you what to put in for here. So your 8 in this case is your K, and then your negative 1 is right here, and your 9 is right there, and then the 8th is the power that you go. So this is how we do this count. It's not, I mean, you do need to practice this, especially when you guys go to count 2. Now, this is a question that we will use your formula here. So in order for you to use this formula, this is a constant. So constant will be this formula. So when you use the constant formula, this is actually is 9 plus 9 plus 9 plus 9, 12 times. This is 9 plus 9 plus 9 plus 9, 12 times. Okay, so that means you just need to take 9 times 12. Anyone know what 9 times 12 is? 108, right? So if you have this is the same thing as Cn. Cn means you take the number 9 and times 12. This is only happens when this is a constant term. Okay. Now we got this. This is look exactly like number 2. So that means this is actually is 1 plus 2 plus 3 plus 4, and you add all the way to 43. So what we do here is, this is the formula we use. So your n in this case is 43. So you have to use your calculator. 43 times 42, 43 times 44, because you add 1. So it's 43 times 44 divided by 2. Okay, so you have to divide that by 2. So anyone know what that is? 43 times 44 divided by 2. Calculators. 43 times 44 divided by 2. And that's your answer in this case. So it's pretty much straightforward if you want to use this. That's why it is given in your test. So you do not need to memorize this formula, but make sure you know how to use it. It's 946. So that means that if you add 1, 2, 3, 4, 5 all the way to 43, that is how you do the add in this case. Now this one is a little bit tricky in this case. This one, what you need to do is you can separate. So if you have like 2 terms, you can separate them. So this is like number 3. So if you have 2 terms here or 3 terms, you can separate them. So this is actually, if you want to write this, this is actually is the sum from 1 to 5, 2k, minus sum 1 to 5, 8. Now, the sum 1 to 5, 8 is easy to find. The reason why I say this is easy to find is because this is not a constant term. So if it's not there's no constant term, you just multiply it. So that means you multiply 8 and 5. So this sum of 1 to 5 in this case is actually 40. So we know this is net 40. Okay. Now the question is to find the sum of 1 to 5, 2k. Now, what is the sum of 5 to 2k is we have to use this formula. Okay. So your k in this case is 5. So you have to add 1 plus 2 plus 3 plus 4 plus 5. So you can add it up very easily. So if you do 1 plus, so this one is, the first one here is actually you have to take, I don't know what happens. You have to take 2 times 1 plus 2 plus 3 plus 4 plus 5. Why we have to put a 2 in front? The 2 in this case because of this 2. And then the k in this case is 1, 2, 3, 4, 5. So 1 plus 2 plus 3 plus 4 plus 5, this is actually is 15. So 15 times 2 give us 30. And then you have to subtract 40. So that will give us negative 10. Okay. So a bit more difficult, and see, this is all getting more tough here. So again, how do we do this? Is we have to do the sum from 1 to 4 of k to the power of 3. And then you add the sum from 1 to 4, 5. Now this is, again, this is no variables involved. So if there's no variable involved, you just multiply the maximum with the 5, the number. So 4 times 5, so we know this is 20. So the sum from 1 to 5, sum to 1 to 4 for 5 is 20. And now this one is a bit hard. So you have to use the formula for power 3. So if you remember the power 3 formula, the power 3 formula is n plus 1 over 2 squared. And n in this case is 4, because we have 4 here. So this is going to be 4 times 5, because 4 plus 1 is 5, over 2. And then you have to take the whole thing square. So 4 times 5 is 20. 20 divided by 2 is 10. And then you square the whole thing, so it's 100. So 100 plus 20, you get 120. So for this question, you will get 120. You guys know how to use this formula now? Okay, it's very important. And the last one that we do here before we move on is doing, because running out of time already, is doing this. So in order for you to do this part, because of a 10 here, so you actually have to do the sum 1 to 30 of 9k minus the sum of 1 to 9 of 9k. So you have to, the reason why you first find all the 30 sum and then you subtract the first 9 sum, because your k here starts from 10. So if your k starts from 10, then you will have to start minus 1. You do 9 here. So how do we do 9k in this case for 1 to 30? Is you take 9 times, now the k formula, if you use the formula for k, the k formula is given us the second one, n plus 1 over 2. So n in this case is 30. So you take 30 times 31, because you add 1, divided by 2. And then you minus 9. The 9 came from the 9 here. And then you do the same thing, but this time this add to 9. So it's 9 times 10 divided by 2. So you have to add 1 in this case. So then you use your calculator to figure this one out, and then that will be your answer in this case. So 9 times 30, 30 times 31 divided by 2 is 465, and then you multiply by 9. This is 4185. minus, and then you do 9 times 10 divided by 2. You have to use calculator here. And then times with 9. This one is 405. And then you subtract these two numbers. You will get 3780. So this is how you get the answer in this case. So this answer should be 3780. Okay. So this is how we figure out using your arithmetic sequence here. The next one we're talking about is your arithmetic sequence, which is not too difficult. So that I think I will let you guys do it your own for arithmetic sequence, because they are pretty much straightforward type. Because the only part about arithmetic sequence here that I want to point out is the three actually. The first formula is the D. In order for you to find D, you take your second term minus the first term, or your third terms minus your second term. So you have to take your previous term minus the first term. So a lot of students make mistake here is they take the first term minus the second term, should be the second minus the first, okay? And then the second formula is called an arithmetic sequence. This is the arithmetic sequence where you use an equals to a1 plus n minus 1d. So this is the question. If a question wants you to find the nth term, then you use this formula. If a question wants to use the sum formula, sum of the arithmetic sequence, you use this. They got two formula for sum. One is using this, where if you use this, if you doesn't know the last term, you only use the second one if the last term is given to us. So there are two formulas here. The last formula is used when the last term is given to us. This one is used when they don't give you any last term. You just give you the first 5 terms or 6 terms or whatever terms you have. Okay. So what I want to tell you is read the instruction carefully, and they will tell you finding the nth term or finding the sum. And yes, a lot of students will ask me, will the test tell me that this is an arithmetic sequence? The answer is yes. So in the test, they will tell you this is the arithmetic sequence, this is a geometric sequence. So do not mix those two up, because 13.2 is arithmetic. The next section is 13.3 is geometric sequence. So main part of arithmetic sequence in this case is like here, if you want A1 is your first term. To find D, make sure you take the second term minus the first term, so you get half. And they want you to find the 90th term. So in order for you to find the 90th term, you have to use this formula, A1 plus n minus 1D. And A1 in this case is 2 plus n minus 1. That means you subtract 90 from 1, you get 89 times D, in this case half. And then you write your answer. Sometimes, again, it can be in fraction or it can be decimals. I'm not that picky, but your online homework is picky in this case. This question asking you to find the sum. So once you find the sum, the good news about this is they know the last term. So you can use the formula of A1 plus AN, because A1 is 1, AN is 547. But unfortunately, we do not have n terms here. And class, please do not use your calculator to add 1 plus 4 plus 7 plus 10 and keep on adding to 4, 5, 7. That's not what I want to teach you here. So what you need to do here in this question is you have to figure out what is your n term in this case. So in order for us to figure out the n term, you have to use this formula, the second formula, an a1 plus n minus 1d. So we know that a1 is 1. And we know the D is 3 because 4 take away 1 is 3. And the 4, 5, 7 is your AN term. So you are solving for N in this case. And once you solve for N, which is 153, then you can use your formula to find the sum in this case. So the good news, the good news is you know the last term. The bad news is we do not know what is the term for 4, 5, 7. This is how you figure it out. For these questions, you have to figure out what is your first term and what is your last term. The n term is given us by 100, so you do not need to worry about your n term. So how you find the first term is you plug n to become 1, you get 5.5. And then you plug n to become 100, you get negative 44. So this is how you figure out your first term and your last term. And then the n is 100, and then you plug all this into your formulas. the same formula, and you get negative 1925. Okay. The word problems you will get in this kind of questions will look something like this, where it's talking about if your first, you got 36 rows of seats in the auditorium. The first seat is 15, the second seat is 18, and the third seat is 21. So the question is asking for is how many seats we have. So this is where you will use the sum of the 36 seats. Since we doesn't know what is the last, how many seats the last row is, so we use the other formula, 2a1 plus n minus 1d. So you don't forget, you got two formulas if you want to find the sum. Since the question here doesn't provide us the last one, so you have to use this formula in this case. So mostly the arithmetic sequence is a little bit easier to do. The most difficult part is the geometric series, sequence and series. This is the one that is a bit more difficult because now we don't add, we multiply. So don't forget that when you multiply like 1 to 5 to 25, so if you are multiplying this by the same like 5, that is your R. We don't use D here, we use R, we call it common ratio. Your R can be a fraction too, like 2, 1, 1/2, 1/4, 1/8. So how do we know your R is a fraction? It's very easy. Your sequence is getting smaller. You can tell that 2, 1, 1/2, 1/4, the sequence is getting smaller. So you get the 1/2. And if your sequence is getting bigger, it's called is 5. If your sequence is called bigger like this, we call it convergent sequence. And if your sequence is getting smaller and smaller, it's called a divergent sequence. So that's the meaning of convergent, divergent. The formula, there are quite a few formulas here. So how you find R is you take the previous, the an over an minus 1. So you have to take like 1 over 2, or 1/2 over 1, or 1/4 over half. So this is how you find your R. Your an terms is a1 Rn minus 1. So this is how you find your an terms. In order for you to find the sum is a1 1 over Rn over 1 minus R. So this is called the finite sum. What's the meaning of a finite sum? Means you know what, it never ends. Finite means that the sum never ends. So it doesn't have a dot, dot, dot behind, okay? The next formula we have is an infinite sum. Infinite sum means you keep on adding. So that's the difference you see. The infinite sum is you see the dot, dot, dot. That means you keep on going. The finite sum means you stop, okay? So this is called a finite sum. So the infinite sum, it depends. If you have a convergent series, then your formula is very straightforward, a1 1 minus R. If it's a divergent series, you cannot find the infinite sum in this case, okay? And then the annuity formula is given us here. So mostly in this example here, what you guys need to watch out is figure out the sum. This is a lot of people make mistakes here. So like this case, this is a finite sum. How do I know this is a finite sum? It's because on top here is not an infinity symbol. So that is a finite sum. And once you see an infinite, when you have an infinity symbols or you do dot, 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 dot like this is how we know this is the infinite sum. So usually when you have an infinite sum, it should be infinite, not finite. It should be infinite geometry series. Usually we have either they are converge or diverge. So, so if this, let's take a look at number 8. So this is the finite sum. This is a formula you need to know. So find the finite sum. So A1 is your first term. And how do you know your first term is you plug K become 1, you get 2/3. And then you need to figure out R. So R in this case, you just figure out A2. So you plug K become 2, so become 4 9. And then in order for us to figure R, you just divide this, you get 2/3. So now you know A1 and R, you just plug into this formula. And then your answer in this case is going to be n term. The reason why is because this is an n term sum. Cannot figure out. But once the n become 12, then your answer can be in decimals or frac. Then you have your answer is not in the n term. So if you have such case, if a question giving you something this format where you have a k minus 1 on top, this is 1, automatically the 16 is your A1 and the half is your R. Okay, so if you have this, you can automatically use that. The reason why we cannot use that in question 8 is because your k here is not -1. Okay, so if this is k is -1, then automatically your A1 is 1 and your R is 2/3, but this is K and this is K minus 1. So that's what you need to watch out for, is this kind of two things. One is K and one is K minus 1. And then for the infinite geometric series, you just need to figure out if your R is less than or greater than 1. If your absolute of R is less than 1, it's converge. If it's converge, you use this formula. If absolute of R is greater than 1, it's called diverge. If it's diverge, you cannot even find the sum. Okay. So first thing first, like this, you find what is your R first, and your R in this case is negative 1,5, which in this case is less than 1 if the absolute value is converge. So this is your R, and then your A1 is 15. So you just put it into this formula, and you will get 12.5. So it's very easy to figure out the formula. The formula is very short, but the most important part is figure out, are they converge or diverge? Like this case, your R is 0.2, which is less than 1. So this is converge. So you can use your A1 is 4 and your R is 0.2. Your answer is 5 here. But for 12, your R is 3/2, which is more than 1. So this is diverge. So if you have a diverge sequence, you cannot find the sum. Okay, or you can only find the sum when it's a converge infinite geometric sequence. Okay, all right. So mostly is go through my notes, and there are some I recommend you to. They're not that difficult for this the last 3 sections. So make sure you understand this. Does anyone have any questions before we end the Zoom session for today? Your test is tomorrow. You will have the last test tomorrow, which consists of chapter 11 and 13. 11 is a conic section, and then 13 is the series and sequences here that we talk about here. So these are the two. You will have a test tomorrow, and again, it's due on the next day. Make sure you download your Zoom, your cam scanner in your phone, so that you, at this time, I just want you guys to submit this in one nice PDF form. I won't take any multiples PDF. I don't take any picture JPEG form. If you send me those, I will just reply back to you that I'm not taking this, and I will give you 0 in the test. Because tomorrow I have 150 papers to grade, so I want you guys to do that for me. Your final is the next Monday. Your final is next Monday. You also, it's a take-home finals. I think you got around like 17, 18 questions, and it consists of everything you study from the first day to the last day of class. Right? So does anyone have any questions here before I end the Zoom session for today? Is the last Zoom session. We will not have any Zoom sessions in the future. So does anyone have any questions for me before I end the Zoom session? Yes, I post this in D2L. You can watch this again. Anyone? Anyone have any questions for me? All right, if you do not have any questions, you may go. If you do have questions, you can send the email to me, or you can ask me. Okay, so make sure you guys do your homework. This is the last one, no more. Last one, okay? Take care there. I'll see you guys. Hopefully I'll see you guys. Send me your test. I'll check your email for test tomorrow, okay?